Might have been a week. It's pretty fast. They made it and shipped it to me. Actually, I think it's been a week and a half. God damn it, those scissors are dangerous. Hey, easy on my guys. My knife has gone missing. All my knives have gone missing. So, kind of squished down boxes. Ooh, it's the first time I've done this, but look at that. I ordered 5 of them. Ooh, they come in a very nice sealed package. Oh, yeah. Actually, it sits like this. Oh, I hope this works. That top looks a little cracked. Oh, okay. That might be the container. It probably knows the shipping's kind of evil. But there's a destined in there, and yeah, that's cool. So this is going to replace my relay box in there. I got 5 of them. I only got 3 components for enough of them. I'll probably salvage them from the other piece. So, okay, there's the dot. That means this one sit on here like this is the relay and this is the socket I'm going to use. I'm going to strip these wires down and run a solder all the way up and then drop them in the hole. And then I'll have these replaceable breakers, but these will sit on there like that. And I'll have 10 of them on a board. So, and the screw holes came out good too. I should have dropped another support right here in the middle, but I got these over here. And this will be my socket. I might pull that thing off the side, but either way, this will be my socket in there. So I'll have 4 or 5 of these. Then anytime I have a problem, I can replace this relay at any auto store. These are my circuit breakers, or my fuse holders, and actually they are too big, or don't have enough room to fit the fuse down in there, which is kind of annoying because these things are kind of very pricey. So what I'm doing is I'm coming through here and chopping off the couple inches, or not even a couple inches, 1/4 inch or something like that. That way I can slide that down in there, and now I have a fuse holder that my breakers I can reuse from the other one on, and move on. So, circuit board, awesome, right? These things go right down in here. As soon as we get the angle right. Doesn't seem to matter which way I go with them. And the nice thing is they all have these little clips on the bottom of them, so I can go ahead and put them in now before I'm ready to solder. See? We'll come back and solder the bottom. I'm going to drop all the components in. going to take apart, solder, and all these relays together. However, that is a pain in the butt. It also makes this stand way too high. I don't like how high it stands. So the other day I ordered these. These are circuit boards designed specifically for circuit boards, and put them in here. I hope they fit, actually. I haven't even tried them yet. And they fit. Okay, so they'll drop the footprint and the overall size of this down considerably. I got 20 of them. They're kind of pricey. I could not find this whenever I was originally designing it. I have since found it. It seems like as soon as you order something, you can find it after you order it. Puppy dog's barking because I'm talking to you guys. He's like, who's here? Not cool. They didn't meet me first. So we're going to get back to soldering this and getting it back together. So enjoy the time lapse, and hopefully we will be able to have this installed, at least one of them tonight, and hooked up. I'm debating on if I want to run my brake lights through this. I don't actually have to, but it would give me some extra options by running them through it. Basically, there was a guy on YouTube, I think his name was like iOverland or something like that. But he has his hooked up in a way that when he hits his brakes, it engages a, what was it? I think he had some magnets on all his drawers that it engages every time he hits the brake, so it holds all his drawers in place. And I was like, that's not a bad idea, actually. So we're going to go that route. And actually looking at these looks to be a shorter version with a shorter plastic, and they just took and bent over the ends on it to give you the lead sticking through. Very similar to what I was going to do. I was just going to cut those in half, and I could just strip it and see if it helps. But I think these are fine. They even come with the pre-done holes on them for the alignment, so that's even better. So let's see. How do they go in the holes for the alignment, though? That's the other thing. So we gotta make sure everything, the alignment holes don't match up. That's okay. We don't need them. We'll cut them off and set them down in there, and we should be fine. We just need to make sure that the relays match up to all the other standard relays. Oh my gosh, that's in there so hard. And I'm pretty sure I double checked, and this is a standard automotive relay schematic. So number 30 is the output. This is the output, which is this one right here. So yeah, that is the correct layout for this one. So I don't know why the footprint's off, but it's probably just off. So we'll drop that in there and get it going. And then we'll have a much shorter profile for everything. If we redesign this, we'll probably squish all the electrical components together. So we have power coming in. We got the old regulator over there. I replaced it when I was having the generator problems. Basically, if it's hooked up on the up, it goes up here to this thing up here, so all the internals are external. But I can jump both of them to the lower jumper positions, and it allows me to test the relay. And look, it works. And by that working, and that can be set up like that on the board. I don't even have to use that. And it's just anytime there's power here, there's power there. And I can just kind of use it as a bypass, as a cheat sheet as to that the relay's not doing anything. But I can also hook up my accessory cable to this line here, or even up here as a control. But I could hook a high load to this and then run all these off of accessories and have them come on or off when the accessories are on. So, and if I pull the fuse out, it stops working. Good. Put the fuse on, you hear a click, it turns on, the light that tells us this is active is on. Also, I needed to check the polarity of the diode here. So, and that is this one here. And it is way bright, so I'm probably going to drop a dab of hot glue on that to kind of kill the overly brightness of that blue LED. I might just hit it with a sander, see if that diffuses a little and not make it so bright. But there is a circuit, it is working. I gotta finish soldering this one and up on the other side. I am currently out of solder, or almost out of solder, so I don't know how much I'll get done. But I plan on using this somewhere. I think I'm going to use it somehow in the brake system. Maybe just use a couple, I might get me some pref board and just use the screw terminals for connecting wires together for right now. The wiring jumper thing I got for the screw terminals in the ambulance has already broke on them because the connectors are too big for this, and I did not realize that. So these will be just fine, and I'll probably tape over them if I go that way. But for the most part, I like the way it's designed. I wish this was a little closer and I had the thumb things out here, but there's plenty of room to get your thumbs in here to replace them. And do whatever else you got to do to change it up. So I'm going to move this back over to this is hot switched up here. Means you use the positive side, and then it still has the LED here on because the fuse is still good. And there is a version that I was going to make where this goes to a switch where you push the switch down here and light up all the LEDs. But this one, the LED just stays on. It's not a big deal. It'll actually provide light in it. It's a very quick glance in there. It'll have its own compartment where it is isolated from the rest of the thing, so you won't see the LEDs. So you just open up, look at it, all the fuses are good, you close it, you're done. So, cool, it works. Nice. Alright, I'm going to get all these other ones soldered up. Good thing I made them rougher. Golly, they would have been bright as heck. That one has a little bit of hot glue on it. This is basically just testing out the fuse. These are not hooked up together yet. They will be in the future. I want to make sure all the fuses work still good. Alright, now I'm going to go through and remove it from the switching external switch to an internal switch on all these. So this should be only something that's done when you set up the circuit, depending on how you want to have it switched. I just didn't have time whenever I built the circuit to know exactly how I was going to have everything ran. I think I'm going to use these on the DC brake system too, and some other systems on the main cab. I don't know, it adds possibility for errors and problems, but we'll see once we get in there. I'm running into a connection issue with how everything is. So what I'm actually doing is moving the relays in to a position that it doesn't have to go through these outside triggers. It can trigger on the board itself. So let me just go ahead and check this out. So we got power. Here it click. Oh, that's not good. That sounds like a bad relay or a bad joint. Okay, so what I think is going on here with the LEDs, why they're not coming on until I let them off. I think I got them soldered reverse polarity. They're reversed in the connection because diodes are one way. So whenever I let off, the little flash that you're seeing there is the feedback loop of the coil working. I don't know why that LED is not working, but you can hear the solenoid working. This one might be a bad relay. Let me pull it out. Set that on the side. Crap. I can't believe I did. Well, I can believe I did that. I'm sorry I'm vibrating the camera here. I'm using relays off the old relay board because they're cheap and I already got them. Oh, hey. Oh, man, I don't have a flat blade. I was going to say, oh, hey, I can stick this in there and call it good. But not quite there yet. So let's plug that back in, plug it over here. This is kind of rigged. Okay. Oh, yeah, that's why it's not working. Duh. Okay. When that is, I missed it whenever I switched these in the down position. Put these all in their spots. There we go. Now it's working. So as far as I can tell, the relays work, the fuses work. I got those LEDs reverse polarity, reverse directions. So I'll just go ahead and swap this over to the other one. And we'll get this, show you guys kind of how it's supposed to work as soon as I get it swapped over. Basically, by having these like this, I can ground switch either direction. I'm sorry for such a long video. I just want to kind of get this all on one video and not have a divide on it. So I figure this will be quite a bit extensive of a video. Make sure these are back in their holes. Okay. Where they're doing the same thing. I know I tested that one up front. Did I put them all in backwards? Am I that far out of it? Okay, let me set this one up to do it. Because I know I tested one of them. Okay, that one works. Alright, let's see if this one works. That one works. Oh God, I reversed some. Let's see. That one's reverse. God, I must have been really, really tired whenever I did this. That one's reversed. That one's reversed. Okay, so I got, what? Does this one work? Nope. I got 2 of them right, and the rest of them are reversed. Oh boy. I feel silly. Oh well. That's part of doing the troubleshooting afterwards. So, I'm gonna go try to desolder these with what I got if I can. Alright. Hopefully this will be the end of the video right here, but I would like to talk a little bit about desoldering. It's a little bit harder to do on surface mount components, but on through-hole components, it's part of the reason I went with through-hole on this, is it's a little easier to desolder and do some other stuff. This stuff is called solder wick, or you can read it right there. And it's rated wire basically in a way that it wicks the solder off the joint. So when you do it, it'll actually pull it off. And this is a relatively new strand. It's awesome because it's a new strand, but basically it'll pull off all the excess solder and wick it up into the solder wick itself, which allows us to pull off a lot of the extra solder here. You can see how that hole right there showed up? And it's because it pulled it all off. On the newer surface mount stuff, you can do it with a little heat gun. I just am not very diverse with that kind of solder. Connections out. Whenever I solder in place, I wired them out to hold them up so I didn't have to hold it from the backside. And now because the connections are wide and I got a bunch of heat there, it's hard to pull out. There we go. And there's the LEDs with the lack of connections on it. So I'm going to get this cleaned up with the solder wick, and then we'll shove it back in there and solder it back the right way. Speaking of which, this is only one board of 5 I have. I only have enough components for doing 3, I think, unless I want to strip the relays on the other one, which is kind of a pain in the butt. That's why I went ahead and bought these other ones. Oh God, don't tell me I'm killing that one. Yeah, I'm already starting to affect the trace leads on this one. I'll have to stop messing with that one, and this, hopefully we can get it in there right. Let's see. I'll lift you guys up here for a second. I need to know how I got that ran so I know how to run opposite of that. Okay. This should get us back up and going. See if we got it up in there. Kind of. There's a really bad solder, actually. I want to see if I can get a little more heat on it and get it shoved up in there. A little better. One side, now if I can get to this other side. There we go. this ruined the connection. Maybe not. Maybe not. Let's flip it over and test it. I dug down in there and found my alligator clips here. So this is the ground right here. And this is a hot, and darn, it's still not making good connection. I think we may have ruined that because we pulled off the solder lead. But the ones over here work just fine. We got power to the fuse, and we got relays on. And to show that it can be switched off, you just move this jumper over. Now we just have power to the fuse, and that would be a ground switch. And if we want to make a hot switch, we move the jumper back up here. We move this jumper down here or up, depending on which way you're looking at it. And that would make it a hot switch. And you would come up here to what coil this number 4. Come up to coil 4, and being that that would be hot switch, you would feed it into the positive side here. If you want to do the ground switch, you feed it into the negative side there. And if you want to make either or switch, you put both of these in, and you put both of these in the down position, which allows you to control the relay completely outside of the board. So I'm going to mess with these other ones, see if I can get them working right, and I will see you guys a little later. Right, it is done. My first circuit board's completely soldered. The one up here that I screwed up the LED whenever I desoldered it. It's the first time I've desoldered in a while. But the next couple ones, I got 5 more boards to do, but this one is complete. It works as designed. Later on, I can add a power line to this, a flexible line, or I can come through and drop individual power things, so I can power this side from a different battery from this side, or vice versa, or however I want to do it. I have 2 grounds here for each side. This is mainly for operating the switches, the relays, and the LEDs. I also have an additional ground up here. Hello everyone. So as you can see, I have actually completed 2 soldering boards on this. I only had enough of the short boards for 2 of them, so that's fine for me. And I have probably 3 more boards. I tried to do the tall one the other day. This one is already wired for power hookup. This one is wired for whatever extra I want to do to it, add or not add. This is the original design. This has been modified on the same board. But I wanted to do a little bit of waterproofing on these boards because of the compartment that it's sitting in. I'm not sure if there's going to be any water coming in. Also, the ugly solders here is because I don't have a solder board powerful enough, or not a solder board, a soldering iron powerful enough to melt it thoroughly through. But other than that, this board works just fine. I've gone through and tested everything. All I need to do is get relays for it. But it's a good little board and solders up nicely. All the lights work. But what I'm going to do is waterproof the back of it and then waterproof the front of it where I think it's needed. I just really want to get a little bit of water protection on it in case water comes in. So we have this stuff here, and you guys can read it and look it up. I found out about it whenever I was looking at doing drones, and I still may use it whenever I do drone to waterproof your drone. Say you're flying a drone and falls into the water. This is supposed to protect your circuit board. And it doesn't look like much. It smells horrible, which is part of the reason I have the window open. But just come on here and you brush it on and get on all the connections, so when it falls, water droplets come in. They won't fall straight on it. You can't really see what I'm doing right now. Let's see if we can get it so we can see it. And they probably use this in the more of the computer manufacturing technology on the stuff that has to be somewhat waterproof. So what we got here is a UV flashlight. There we can see how horrible or good we have painted on. So it has a UV dye on it, so you can actually see what you got covered and what you don't have covered. And that's why I think it's used in the manufacturing industry for stuff. But we're going to cover up all these little electrical connections here. I'm not too worried about the rest of it. I just want to get all this covered up. And see, without it there, it's not really fluorescent. You kill it, you can't even see where you're putting it. We're going to turn that light on so we can make an ugly paint job look a little better. There we go. And it's all waterproof on the back. I'll do the other side over here and we'll call it good. But that's pretty cool. I can use a UV light to see this stuff to put it on. Right? I'll do the other side too, but it's too high in here. Two VOCs. I'm going to sit in front of the window a little bit more. It's pretty cool, but look, if I take away a light, it disappears completely. You can't even see it, but it's all waterproof. Still shiny and still what it does, and we really know how good it looks. Besides, it needs to dry for a little. That's a spot I missed. But I would like to do all my electronics that way. It's just that stuff is harsh. Anyhow, don't forget to like, subscribe, and share.